Now this is a JAMB question, 2021, and it is question number 40. Which of these will give a fundamental quantity? Which of these options will give a what? A fundamental quantity. I've told you what a fundamental quantity is, which is mass, length, time, luminous intensity, temperature, and others. Which of these, when you compute everything together, this option will it give you a fundamental quantity? Know that if it's giving you the unit, the unit can also give you the fundamental quantity. Now let's quickly see this option number 1. Mass and acceleration. What formula that tell us mass and acceleration? It is what? Force. M times what? A. And note that M times A, it is what? Force. Automatically force, is it a fundamental quantity? No. Force is a what? Derived quantity. As a result of what are you seeing there? A fundamental what? Quantity. They are all together. That means automatically this one cannot be the option. And even if you want to check, this acceleration is as a result of velocity over time. Velocity time. Time is also a fundamental quantity. Automatically it can't. Are we together? And apart from that, even the SI unit, it is Newton or kilogram what? Meter per second square. Are we together? Kilogram meter per second square. Check. Kilogram is a fundamental quantity. Meter is a fundamental. No. Kilogram is a fundamental unit. Sorry. Meter is a fundamental unit. Per seconds is not a what? Per second square is not a fundamental unit. Because seconds ordinarily is a fundamental unit. There is not anything like per second. So this one is out of them. Now let's go to the what? Second option, which is option B. Force. Are we together? Force. And we have magnetic flux density times current. This, let's break this down. This force, you can't use this formula here. Mass times acceleration. I told you that each formulas depend on some topic under physics. Note that this force here, and you are seeing magnetic flux density here, mean this force, it is not the force of this one. It is another force of entirely that are related to this magnetic flux. Which is that? Go and check magnetic field. We have the force to be B-I-L, where B stands for what? Magnetic flux density, I stands for current, and what? L stands for what? Length. This force is different from this one. Each topic tell us how the force is going to be. Now, wherever I'm seeing force, what will I be putting? I'll be putting what? B-I-L. Are we together? So therefore, there I can say, since I'm seeing force here, I can have it to be what? B-I-L. All upon, this is a force now. Magnetic flux. Magnetic flux, I told you, B stands for magnetic flux. Wherever I'm seeing magnetic flux, what would I be putting? B. Times, what is current? Current is what? It is a fundamental quantity, and it is I. That is the symbol. Now all we need to do, let's do a mathematical computation. B settles B. This is also I. I settles what? I. What are we left with? We are left with what? L. Is it L or per L? Ordinary L. And you know that ordinary L fall on what quantity? See, fundamental quantity. Because out of the basic quantity in fundamental quantity, length happens to be them. So this B is the correct what? Option. I won't go for C. Why? Because C, what is C? Force. Force is what? Mass times what? Mass times what? Acceleration, isn't it? Already know that this mass times acceleration is what? Is out of it. Because we have seen a what? A derived quantity there. We can actually get the answer. And this one is F what? Ft. Another force there. It's also from fundamental quantity. So we can actually get it here. Are we together? See this potential difference as well. Potential difference is V. I told you earlier. Times work done. Work done is also what? Work done is also V times Q. Automatically know that Q, it is not, Q is not among a fundamental quantity. Are we together? So D, C are not the options. B is the what? Correct what? Correct options for this JAMB what? JAMB exercise. 2021 under JAMB. Which of the units of the following physical unit are derived? I've told you what a derived unit is. Or they are now asking us which of these physical quantity are what? Are derived what? Are derived. Are we together? Note that what are we having? We are having area, we are having thrust, we are having pressure, we are having measure. Mass, sorry. They want us to what? Find a derived unit. I mean a derived quantity here. Note that in our earlier video, I have told you that area is what? Is it a fundamental quantity or a derived quantity? It is what? A derived what? Quantity. L times L. L is from fundamental. Another L from fundamental. Coming together of them, that is what form area. It is derived. Combination of fundamental quantity. That has gone. That means this is one of them. We are looking for a derived quantity out of this option. Thrust. Thrust, another name. They just want to use that to convince us. Another name. They call what? They call force. Force in physics. You can also call it what? Thrust. Force can also be called what? Force. Can also be called this as what? Thrust. Force is what? Is a what? Derived what? Quantity. Which is mass times acceleration. Mass is from what? Fundamental quantity. Are we together? That means thrust is also area, thrust are derived quantity. Are we? What of pressure? That means this one is also there. What of pressure? Pressure is as a result of what? Force over area. Automatically, force is from what? Derived quantity. Area is also from what? Derived quantity. Are we together? As a result of what? What form force? Mass and acceleration. Mass is from what? Fundamental quantity. That means this pressure as well is also a derived what? Quantity. Because what compressed this to form force and area is as a result of what? Fundamental quantity. Now, that means I, 1, 2, 3 are derived quantity. And we ask which of these units of the what? Following physical unit are derived. That means this is derived, this is derived, this is derived. What of mass? Mass is mass. There's not anything like coming together of two or more quantity to form mass. So mass is mass, and mass happens to be number one from the fundamental quantity. So this is an exceptional case. It is exception from them. That means what will be the answer now? 1, 2, 3. Now let's find where is 1, 2, 3 here. We option A 1, 2, 3, 4. This is wrong. Option B 1, 2, 4. It is also what? Wrong. Option C 1, 2, 3. That means this is the right answer. While option D, it is also what? Wrong. Area and mass. There are two things. This is fundamental. Why this is derived? They can. What they ask us is all derived what? Quantity. That is that under that question. So the correct answer is what? Option what? Option C. Under physics, under fundamental and what? Derived what? Derived quantity, which is fundamental unit and also what? Derived unit. The correct unit of energy density is what? Now, firstly, you go and check for the formula for what? Energy density. What is the formula for energy density? Energy what? Density. What is the formula? The formula for energy density is what? Energy all upon what? All upon what? All upon V. All upon volume. Are we together? Now, this energy, I told you that in dimension, this energy is still the same thing as work. And work, that means E is still the same thing as W. And work is what? Force times what? Distance. All upon what? Volume. Are we together? Now, what are we looking for? We not ask the what? The formula. We are asked about the unit. They ask us the unit. So let's be breaking them. The unit for force is what? We don't have Newton here. We have kilograms here. So I'll work towards using kilogram for the unit of what? Force. Are we together? That means we have it to be what now? ED now will be what now? Will be what is force? Kilogram meter per second square. Please, you know how to get this from mass times acceleration. Times what is D? D is distance, which is meter. All upon volume. What is the SI unit for volume? It is a derived quantity, right? Which is volume is length times breadth times height. Which is what? Meter. Length is meter. Breadth is meter. Height is also meter. Which is meter what? Meter cube. Right? Now, meter settles meter. Remain how many meter here? Remain 2 meter. Another meter is here. Settles another one. Remain how many meter here? Remain 1. Are we together? Now let's try and rewrite it back. There's not anything settling one another again. We have kilogram. Then the meter that is here, remain only 1 meter that is here. Bring it up. Law of indices. When this is coming up, It is 1 that is here. When it's coming up and crossing this one, it will be what? M per 1. Are we together? Then what are we left with? We have per second square. Now let's check. This is the answer. This is the SI unit for what? For energy density. Let's check the options. Is it this one? Kilogram meter per meter cube per seconds. Is it? No. Kilogram meter square per square. No. We have C. Kilogram per meter per what? Per second square. What would that be? They resemble one another. They are the same thing. So the correct answer is what? Here, C. The correct answer is C. All you need to know is just to cram the formula. E upon volume, or work done upon volume. We call it what? Energy what? Another question under JAMB year 2022. Which of these is a derived unit? You know that this, the SI unit for the kilogram is an SI unit for mass, and mass is not a derived what? Unit. It is a fundamental unit, which is kilogram is a fundamental unit. Meter, that is for length, and length is a fundamental quantity. So meter is a fundamental unit. Seconds is the what? SI unit for time. Time is a fundamental quantity, and seconds is a fundamental unit. That means the correct option, these and these and these are fundamental units. We are asked about the derived. So option C is the what? Is the correct answer, because it is Newton, force. So that is that. Now JAMB 2022 again. Question number 3. The international agreed system of unit, that is SI unit, for physical measurement for physical measurement, the international one that they do use, I mean the fundamental one. Is it pounds? Is it feet? First, is it in feet? Is it in seconds? Is it gram, meter, or seconds? Is it kilogram, meter, seconds? Is it centimeter? Yeah. What will be the answer here? The one that we use, the physical measurement in physics, per se, it is D. It is C. Kilogram, meter, seconds. This stands for mass, this stands for length, this stands for time. We don't use this. We don't use this. Some other countries use this. Some use this. Some use this. But the standard one, the agreed one in physics is just what? It's just this. Kilogram, meter, and seconds. That is that under that. Thanks for what? Watching. Thanks for what? Listening. Stay blessed. More blessing. I still remember